Every day, on construction sites, workers face a silent danger. High above the ground, heavy steel bars are carried by hand, placing enormous strain on the human body. The risks continue as workers manually lift heavy scaffolding, where a single moment of fatigue or a loss of balance can have devastating consequences. For many, the damage isn't immediate, but years of repeated heavy lifting leads to chronic back pain, muscle injuries, and long-term physical exhaustion. And sometimes, the consequences are far worse. A single accident can turn an ordinary workday into a life-changing tragedy. Manual material handling doesn't just waste valuable time, it puts life at risk.
Hello everyone, I am Oscar, the idea giver.
I'm Adrian, the assembler.
I am Marcus, the coder.
And we are from Team Fly Hawks 5.
What you see is not an isolated incident. It is the true reality faced by most construction workers all around the world. Construction remains one of the most physically demanding industries, which includes manual handling tasks such as lifting, carrying, pushing, and pulling heavy materials repeatedly throughout the whole workday. According to the International Labour Organization, known as the ILO, manual handling is responsible for a significant proportion of workplace injuries, particularly musculoskeletal disorders affecting the back, shoulders, and joints. These injuries often develop gradually, reducing workers' physical capability and leading to lost productivity. Beyond the long-term health effects, the construction industry continues to experience one of the highest rates of workplace accidents. The ILO estimates that at least 108,000 construction workers lost their lives on site every year worldwide. This has highlighted the urgent need for safer work practice and a better material handling solution. Therefore, our objective is clear. Introducing RODOG. RODOG is an autonomous construction material transport robot implemented with SDG 8, which is decent work and economic growth. It is designed specifically for construction sites to ease the work for construction workers.
Now, let me introduce its main functions. Firstly, robot can move autonomously around worksite, monitoring every movement. Secondly, it can detect obstacles using an infrared sensor. Thirdly, when robot detects heavy dust, it quickly moves through the hazardous area while activating its LED and the buzzer to warn nearby workers. Finally, there are manual buttons to allow the user to control the robot whenever it's necessary.
By utilizing these features, this project provides practical benefits for both workers and the construction industry. In terms of health benefits, RODOG directly reduces back pain and muscle strain. By taking on the heavy lifting, it lowers the risk of long-term musculoskeletal injuries and decreases worker fatigue throughout the workday. It also greatly enhances workplace safety. The robot's obstacle detection helps prevent collision on site. Furthermore, the buzzer alerts improve awareness among nearby workers, and the automatic lighting increases visibility in dark environments. When it comes to productivity, robot speeds up the transportation of heavy materials. Because the robot handles the heavy loads, it allows workers to focus on skilled construction tasks and significantly reduces downtime caused by manual material handling. Looking at the aspects of economic benefits, creating a safer work site reduces medical costs associated with workplace injuries. Additionally, continuous automated transport improves overall project efficiency and potentially lowers labor costs for repetitive transportation tasks. Finally, this project brings a positive social impact. It improves workers' overall quality of life
by easing their physical burdens and create safer working environments for everyone.
Next, I will explain the components we use and where they are connected. Our robot uses two DC motors connected to motor port M1 and M2. They provide the driving power that allows the robot to move forward, turn, and reverse. We also use two servo motors connected to port D9 and D10. These servo motors stimulate the cargo container. When the robot detects obstacles, they rotate to open the container so the workers can easily place construction materials onto the robot. The IR photo reflector sensor is connected to port A7. It stimulates obstacle detection. When an object is detected in front of the robot immediately stops, moves slightly backward, opens the cargo container, and activates the warning system. The light sensor is connected to port A6. It stimulates dust concentration. When dust accumulates on the sensor, the light reading decreases. The robot interprets this as a high dust environment, automatically moves forwards, and alerts nearby workers. The LED on port A5 and the buzzer on port A4 work together as visual and sound warning system. Finally, pull switches on port A0 to A3 are used for manual control, allowing the robot to move forward, stop, turn left, and to right during testing and demonstration.